right, let's take a look at this lesson on solving percent problems. In the lesson, you can see that they give you kind of this formula of a rate, and you're going to multiply it by some base value to get your amount that's left. All right, so let's kind of break this down. The rate, that is always your percent. You're taking a percentage of it. If you were taking 50% of it, then you'd be taking half. You're taking a portion of it. And the base is the full value that you're taking the portion of. So this is kind of like the full, what is it that you're trying to take a part of? So there's a percent times the full value, and this is going to tell you what you're left with or what you were shooting for. So that's what the A is. It's the amount you actually have at the end. I guess I'll just leave it at amount. Now, one of the things before we jump in and do some examples that you have to understand about percentages is that when you do computation with them, you need to write them in decimal form. So if you have something like 0.65, that's the value you use within the equation, but that equates to a 65%. So when they tell me 65%, I'm actually going to be typing this 0.65 or writing 0.65. I'm not going to write the 65 number. It's the 0.65. So let's just practice a few of those, just some of the weird ones. Let's say you ended up with I'm going to kind of write this backwards. Let's say it said 2%. All right, well, on this 65%, you're always moving this decimal 2 places. So if you have a 2%, you're going to take the decimal that's here and back it up 2 places. So the number that I would be using in my formula is a 0.02. And that's what 2% looks like when you write it as a decimal. And so I'm kind of putting double arrows because it all depends on which way you're going. If they give you the percent, you're going to convert it back to the decimal. But let's say in the equation you were solving for the percent, then your answer is going to look something like this, and then you're going to convert it over here to this to answer with your little percent sign. All right, so you're always moving your decimal 2 places. Oh, I have one more. Here's the other weird one. What if you had a decimal that was 1.14? Well, that's actually a percent if you move your decimal 2 places. Because notice what you're doing. If you have the percent, you move it left to get to the decimal. If you have the decimal, you move it to the right to get to the percent. So on this one, I'm going to move it to the right, and this 1.14 is actually a 114%. Now, what's worth noting here is that if you take 100% of something, you've taken all of it. So if you're going to take 114% of something, then you're taking more than all of it, which means up here on this formula, if you took 114% of your base value, the amount you have would be actually higher than the base value you had because your percent was over 100. All right, let's just jump in and try some. Now, I've just pulled these examples straight off the practice, so they're straight off your homework, and let's just look at some scenarios. I'm still going to kind of know that I take the percent times the base to get my amount, but they do sort of mix it up. I think it's worth noting also that when you see the word is, that was going to imply an equal sign. And if you see the word of, that's going to imply it's time to multiply. So I'm going to put a dot because that's going to be multiplication. So really, if you remember those two things, a lot of these problems are set up just to fill them in. What is, so that's my unknown. That's what I'm looking for. 30%. Oh, got to move my decimal to the left 2 places. So that's going to look like 0.30. Of means multiply 60. And once you get that equation set up, you're just going to type those values into your calculator. This one's a nice one because the x is already isolated. You're just going to take 0.30 times 60. And you can use a calculator on these problems. These are not intended to necessarily come out nice. So you can use your calculator. So I have x equals 18. So if you take 30%, which is a portion of the 60, but it's not 100%, it's just a smaller portion of 60. So you can see my value is 18. Let's try another one. The next one is actually the same problem. It's just written differently. It says blank is. Well, that's the same as the what is. That's still my x. Is means equals 5%. Oh, that's that single digit thing. Remember that if it's a 5, I'm going to have to back my decimal up 2 places. So it looks like 0.05 when I do the computation. Of means multiply 371. I'm taking 5% of this base value of 371. 5% isn't much. I'm looking for a pretty small number here. So 0.05 times 371. I can do that in my calculator. And these don't necessarily come out nice. So I have x equals 18.55, which is a very small portion of the 371. All right, let's try one more. Again, it's actually the same thing, just rearranged and looks differently. So here's my percent. Oh, look, it's over 100%. That's kind of the weird one because you're going to take your decimal and you're going to back it up 1, 2. And so as a decimal, that's going to look like a 1.02. Of means multiply. 170 is that full base value. So I'm taking 102% of 170 is, I'm going to call it x. Now, if I'm taking over 100%, remember your answer should be over the base value. So I have a 1.02 times 170. It's going to get me 173, just a little bit higher. X equals 173.4. Now, that's sort of one scenario where you're really on all of these, I was looking for that amount. They gave me the percent, they gave me my base, and ultimately I just multiplied those together. Let's try some that are set up differently. On this one, it looks like I still have my percent. So let me go ahead and I'm just going to jump in and do this top left one. It says 70%. To do the equation, I got to back the decimal up 2 places. So that's a 0.70. Of means multiply. And then it says what number? Oh, I don't know what number. So I'm going to put an X there. Is 84. Now, when you're doing this scenario, my x, my unknown, is caught up in here being multiplied by 0.70. So to get the x by itself so that I can solve it, I want to undo that multiplication. So I'm going to divide both sides of my equation by 0.70. So when I divide by the 0.70, it undoes the multiply by 0.70, and those just go away, and x is here. And then in my calculator, I'll do 84 divided by 0.70. And I get x to be 120. Now remember, what we're sort of looking for here is the base value this time, because I've got 70% of some base value is 84. So 70% of 120 is a portion of 120. It would get you to the 84. Let's try another one. Set up a little bit differently, but it's the same idea. 561 means equals 108% of something. So again, this is going to be that base value that I'm searching for. I'm going to take 108% of it and end up at 561. Now the 108% is written 1.08. Of means multiply, and I'm just using an x. You can use any variable you want. I'll use a b this time for the base. So 108% of something is going to land you at 561. Well, the 108 is going. This 561 is going to end up bigger than my base because I went over 100%. Now again, since I'm multiplying here, if I want to solve for b, I have to undo the multiply by 1.08. So I'm going to divide both sides by 1.08. It will cross that off and it'll get my base value by itself. When you take 561 and divide it by 1.08, you get 519, and I have a 0.4 repeating. So you have to pay attention to your directions on what they want you to round to. I'll just round to the tenths on that. So the base value was 519. When I took 108% of it, I got a little bit higher than 519. I got the 561. All right, last one of these. They did start throwing in some of the word problem things that are like really the whole point of doing this is to be able to apply it to something. So this one says you have a minimum down payment to obtain the best financing rate on a house. Okay, so you got to pay 20% on this loan that you're going to get. Assuming that John has set aside $27,000 and wants to take advantage of the best rate, what's the most expensive house he could purchase? All right, now he's going to pay 20% of the full house, and then that's going to be the amount he pays. So I'm just, like I said it out loud, now I'm going to write it. He's going to take 20% of the full house price, and that's going to equal what he pays, the amount he pays. Now let's fill in numbers where we can. Well, 20% is 0.20. Of means multiply. And the full price of the house, we actually don't know that because we're looking at how great of a house can we get? What's the most expensive house he could get? So that's my unknown. I can call it X, I guess, in this case, equals the amount he pays. Well, what he's saved up is the $27,000, and that's what he's willing to pay. So 20% of how expensive of a house will get him to that $27,000. Again, you got to undo that multiply and divide to get the X by itself. So X is equal to 135,000. So if he were to get a $135,000 house, he'd have to pay 20% down, and 20% of that is his $27,000 that he's saved. All right, I have one other scenario that will play out, and this is the one where they're looking for the percent. So let's do some of those. What percent of 240 is 96? So let's just make an equation. What percent, that's my X, of means multiply, 240 is means equals 96. And just like we did on that previous slide, to undo the multiplication so that you can get X by itself, you're going to have to divide. So I'm going to divide by 240. That'll make the X sit here by itself. And then in my calculator, I do 96 divided by 240. And I actually get a decimal here. I actually get 0.4. Now remember, you're looking for the percent. So you have to convert that decimal version of your percent back to what it looks like with a percent symbol. So you take your decimal and you got to move it 2 places to the right. Well, if you only move it 1, you're at 4. If you move it 1 more, you're at 40. So you have to add in a 0 there to allow yourself to move that decimal 2 places. All right, let's try another one. It actually looks like it's set up the same way. What percent of 98 is 287? Okay, so sort of what jumps out at me, I'm looking at a percent of 98, and somehow or the other, I'm going to end up with a bigger number. So what does that mean to you for your X, for your percent? If you're going to end up with a bigger number, that X is going to be larger than the base value of 98. Let's see what we get. You take 287 and you divide it by 98, and you are at 2.92857. I'll just leave it there. And now it feels like you want to say that's 2.9%, but remember, it's going to end up over 100% because it got bigger, and you still have to move that decimal. So I've got to take my decimal, just like over here, I moved it 2 places to the right. I'm going to move it 2 places to the right. And so I probably didn't round that correctly. Let me throw in a couple more variables because you know they'll count you wrong if you round it wrong. So if it went 5, 7, let's say, I'm going to go ahead and round to the tenths value. So I'm going to go 1, 2. So it's going to be 292%. That's massive, okay? 292. And then I'm going to go one more decimal, which takes me to the 8. But the 5 is going to round the 8 up to a 9, so it's going to end up 0.9%. So I did notice that this was quite a bit larger than the original base, so that's why your percent ends up getting really, really big. All right, last problem I'm going to do with you here, taking that idea and turning it into some sort of a situation where you would set up this equation. Suppose that in 2006, Japan produced 5, I'll write this bigger. I hope you're not reading this on a phone because, man, these are tiny if it is. All right, so Japan, I'll even change color for us. So Japan produced 5.182 million computers. The total world population, the total world production actually produced 189 million. So Japan did 5.182 million, but the whole world did 189 million. What percent of the world's total production of computers is contributed by Japan? Now that statement right there tells you exactly how to set up your equation. It says what percent, so that's what I'm looking for. X is my percent, so what percent of the world's population, 189. And in fact, since they are both in millions, you don't really even have to write the zeros. You could, if you felt like you needed to, you could add a bunch of zeros. But since they're both in millions, it actually, when you divide it out, it will play out the same way. So I don't know, do what you want to do. I'll even write 189 mil like that. So, sorry, got sidetracked. What percent of the world's population is contributed by Japan? That's 5.182 mil. So there's your little equation. You're solving for X. It's your percent. So you're going to divide by the 189 million. Divide by 189 million. So the million part is going to cancel out. If you'd added a bunch of zeros, it would have canceled out. So let's just type in our calculator 5.182 divided by 189, and I'm getting X to equal 0.0274, but that's my decimal version. Now to actually answer this as a percent, you have to move your decimal 2 places to the right. So it's going to end up at 2.74%. And again, pay attention to what they want you to round to. Last time I only went 1 decimal place, so I will here as well. 2.7 because the 4 does not round it up to an 8. So it's 2.7%. All right, so there's several examples. Hopefully that helps you out in figuring out how to set up your equations on this. Good luck.